Earlier, we talked about how benchmark fractions are helpful for estimation. They are. They're just common fractions that you can use to estimate the value of other fractions. Here's three really common ones: 0, 1/2, and 1. A fraction is very close to 0 when the numerator is very small compared to the denominator. A fraction is close to 1 when the numerator is very close in size to the denominator. And a fraction is close to 1/2 when the numerator is about half the size of the denominator. So let's come up with some examples here. Let's say that I had a denominator of 99. 98 over 99 would be very close to 1. The numerator is almost the same as the denominator. Now, what if I wanted it to be close to 0? Well, then I might choose 1 over 99. 1 out of 99 is going to be very close to 0 because the numerator is far away from the denominator. Let's see, half of 99. That's going to be around 50, right? So I could have 50 over 99. And that would just be a little bit more than 1/2. So this is one way that I can use these three fractions, 0, 1/2, and 1, to estimate the value of fractions that I'm less familiar with. I know because I'm using estimation that 1 out of 99 is close to 0. 98 out of 99 is close to 1. And 50 out of 99 is close to 1/2. Estimating with benchmark fractions is an efficient skill to have that'll help you do math with less frustration. So let's use those number lines that we made earlier to write a fraction that is less than 1/2. Exactly 1/2. Greater than or equal to 1/2. Close to but not equal to 0. Equal to 1. Close to but not equal to 1, or exactly 0. All right. I am going to stop talking and I want you to pause the video, and for 3 minutes, I want you to work on your own to think of examples of these, as many as you can. Great. Now that you've had some time to work on your own, let's talk as a class. Talk with your partner. See what fractions they chose. Did you choose the same fractions? Are they different? Are you both right? Check your answers. And then, as a class, I want you to compare your answers and see which fractions you chose for each exercise here. Pause the video, have a discussion, and then hit play when you're ready to move on. All right. I hope you had a good discussion about the fractions that you generated in exercise 2. Let's look now at exercise 3. It tells us to write the unknown numerator or denominator so that each fraction is close to, but less than 1/2. We want each of these to be a little bit less than 1/2. Here's how you do this, guys. So 12. What I want you to think about is, what is 12 divided by 2? It's 6. That's easy. So a number that would be a little bit less than 1/2 would be 5/12, because 5 is a little bit less than 6. That's how this works. Now, what if we were going the other direction? What if we had the numerator and we wanted a denominator? Well, here, 9 times 2 is 18. So I'm going to put a 19 on the bottom. That means 9 out of 19 is a little bit less than 1/2, because 9 is half of 18. 9 isn't quite equal to half of 19. It's a little bit less than that. Now, the other 4 remaining problems are here for you. Pause the video, and I want you to spend 2 minutes working the remainder of these problems on exercise number 3. When you're ready to move on, hit play. You've hit play, so you must be ready to talk about these activities. Well, let's see. 27 divided by 2. 13.5. So a numerator of 13 would give me a fraction that's a little less than 1/2. 8 times 2 is 16. So if I put 17 in the bottom, my numerator will be slightly less than 1/2 of my denominator. 7 times 2 is 14. So if I put 15 in the bottom in my denominator, then my numerator will be slightly less than 1/2 of my denominator. 13 divided by 2 is 6.5. So if I put a 6 in that numerator, once again, my numerator will be slightly less than half of my denominator. And that's what causes a fraction to be just a little bit less than half. The numerator has got to be a little bit less than half of the denominator. On this activity, I want you to get started on your own. What you're looking for is a number, a fraction that's less than 1, but very close to it. Close to 1, but a little bit less. Try this on your own. Set a timer for 2 minutes and hit play when you're ready to talk about these fractions. You've hit play, so that means you're ready to talk. Check it out. 16 out of 17, 7 out of 8, 13 out of 14, 9 out of 10, 17 out of 18, and 11 out of 12. In each case, the numerator is 1 less than the denominator. That means that each of these fractions is almost 1. Not quite, but very, very close. Now you guys really understand benchmark fractions. And since you understand benchmark fractions, you can use them for estimation. There's 3 problems here, and I want to work some of them together. Really, I just want to work the hard one together. You guys can do the easier ones on your own. Let's do this hard one. So down here, we have 10 out of 11. What I want you to think is that value closer to 0? Is it closer to 1/2? Or is it closer to 1? 10 out of 11 is close to 1. 11 out of 12, is that closer to 0, 1/2, or 1? 1. 12 out of 13, close to 1. 13 out of 14, close to 1. 14 out of 15 is also close to 1. So that means that our estimate is 5. If I add these numbers together, will I get 5? No. I will get a number that is almost 5. Because each of these values is almost equal to 1, the sum of them will be almost equal to 5. Now you guys are going to work with a partner and set a timer for 4 minutes. I want you to do part A and part B. Pause the video, set a timer for 4 minutes, and you do part A and B.